Okay, let's go ahead and record the notes now so that way we can get this section done. Please make sure you have your notes completed before you come to class. Now, we did get through some of it. Again, remember what I told you. You need to start turning in your notes to me the day of the test. So this is going to be due the day of the test, your notes. Before you take your test, they're due. If you give them to me after, I will take them, but they will be late. Now, we went ahead and started. This part is already recorded and on Blackboard from that one day that we did have class. Let's go ahead and turn the page. Here is page 2. As a quick reminder, I told you that there's 3 parts here, or 3 rows for you to finish. Let's go ahead and get those done together. AL, again, you're going to need that periodic table with you. I know that you have the formula chart that has a periodic table on it, and you should start printing it out and having it with you, because when you take your test, that's all you're going to have in front of you is the chemistry formula chart, and it has the equations that we use as well as the periodic table. So I just suggest to print that out. Having the periodic table in front of you, AL is aluminum. Now, aluminum is a metal, even though he's on the metalloid stair steps, and we'll talk about that in just a moment in our notes. So we need to know the number of valence electrons. How do I do that? I go up to the group number, which is 3A or 13. Now, 13 really is a group number. We ignore the 1 and we call that group 3. What is the electron dot, or it's also called the Lewis dot structure? So on quiz or test, if you see electron dot, that's the same thing as a Lewis dot. And as a quick reminder, let me go ahead and write that on here. The electron dot or Lewis dot structure are the outside electrons only, right? Or the valence electrons only. And they rotate clockwise. So you start at the top, and then you put the next one to the right, you go to the bottom, go to the left. One, and then you, if you have more, you go again to the top and draw another dot to the right, bottom, left. Now, we write AL, the symbol for aluminum, and then we're going to go ahead and fill that in. It's in group 3, so let's go ahead and fill it in. 1, 2, 3, and we're done. Now, looking at the valence electrons, we can decide whether or not is this atom going to lose or is it going to gain electrons. Now, there's 3 electrons here. To make it a full shell, it should have 8. 1, 2, 3, 4, 5. It's missing 5 electrons. Now, an atom is pretty darn smart because it knows that it wants to do the least amount of energy. Okay, just like a person, right? I mean, why would you do it the long, hard way when you can do an easier shortcut? Here, it's easier to lose 3, and it takes less energy to lose 3 electrons than it is to gain. So the ion that is going to be formed is going to be an Al, and we're going to do a plus 3. Even though it lost 3 electrons, the plus indicates that it has 3 more positive protons than negative electrons. Okay? And who does he look like? Well, let's go to aluminum, who's over here. He's either going to have to gain 1, 2, 3, 4, 5 electrons, or he's going to lose. Let's look at this and let's work our way backwards. 1, 2, 3. So he's going to look like neon when he's done after losing those 3 electrons. Let's go to the next one, N. N is going to be a nonmetal, nitrogen. Here he is over here. So nitrogen. What group is nitrogen in? Group 5. Even though it says a 15, we call it group 5. Let's go ahead and do the Lewis dot structure. Write the symbol. Start at the top. 1, 2, 3, 4. Now that we have another one to fill in, we go back to the top. 5. Now we have 1, 2, 3 more places. Is it easier to gain 3 electrons or to lose 5? It's going to take less energy to gain 3 electrons. And after it gains 3 electrons, it's going to be an ion, which is going to have the symbol N, and then it's going to have a -3. Even though it gained 3 electrons, it has a -3. What does that negative indicate? It indicates that it has 3 more negative electrons compared to the number of positive protons. Who does he going to look like? Nitrogen is right here. He's going to gain 3 electrons, so we're going to move to the right. 1, 2, 3. He's going to also look like neon. Let's go to the last one, lithium. Lithium is a metal. Lithium's over here on the periodic table. So Li, what group is lithium in? Group 1. Li, let's do the Lewis dot, which is 1 electron at the top. Is it going to gain 7 electrons or lose 1? It's going to take less energy to lose 1 electron. So lithium, and it's going to be a +1 ion. And who is he going to look like? Helium when he's done. Okay, so there we go. We have the chart completely filled out instead of you having to do it on your own. If you did do it on your own, go back and check it. See if it's correct. Then we talked about a little bit about our groups here. Remember, group 13, 14, 15, 16, 17, and 18. We scratch out or ignore the number 1, and we call it group 1, 2, 3, 4, 5, 6, 7, 8. Okay? Those are the ones. These are all cations, and these are all anions. This one is going to be one that's actually going to share, and we'll talk about those later. What's it called when they share electrons? And over here, they're already full with 8, so they're happy. They're not going to become an ion ever. Okay? Let's keep going. Here's where we're at in our notes. Again, this is a really short unit, and the reason why is because I know that this is something that is taught in middle school. It is something that the teachers must teach, so it's probably something familiar to you. So this unit itself is going to go through pretty quickly, even though we lost a week of school. Groups or families, they look like columns on the periodic table. They're actually going to be columns up and down. Okay, so what we call groups or families are going to be the columns that move up and down on the periodic table. Now, they're designated by numbers 1 through 18. Okay, these are groups also. Group 3, Group 4, Group 5, Group 6, Group 7, Group 8. But when it comes to bonding and other things, we really don't talk about them very often. Those are metals. They don't do a lot of bonding like anions and cations over here. Okay, and so that's the reason why, even though this is truly Group 3, we call this one Group 3. It's 13. But we just call it 3 because we really don't talk about them because they don't do all this bonding so easily. Okay? So let's keep going. Group numbers represents the number of valence electrons, right? Which are the outside electrons. They have, if they are in the same group or in the same family, they're going to have the same physical and chemical properties. Okay, so what do we mean? For an example, group 1, everybody in group 1 right here, that's up and down, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Okay, all of those are going to have the same physical properties and chemical properties. Why? Because it's about the valence electrons. The valence electrons is what does the bonding. So even though this guy, rubidium, is bigger, it's a lot fatter than hydrogen. Why? Because there's more electrons here. The outside electrons are the only ones that are doing the bonding. His one outside electron is going to bond just like his one outside electron. Don't get me wrong, he has 36 other electrons inside, but they're going to act the same, even though they're different sizes. Okay? Let's keep going. Periods. Periods are also called rows. And rows are going to be horizontal, and they are side to side. Okay? How do I remember this? I write a sentence like this horizontally, and then I put a period at the end. So horizontal, not the up and down. Designated by numbers also. I don't know if you noticed it, but they're actually numbered 1 through number 7. Here they are. Row 1, row 2, row 3, period 4, period 5, whichever word you want to use, 6 and 7. But Miss Munson, what about those? Remember, this one right here actually squeezes in here. The video told us. And this one right here squeezes in here. So this little grayed out area is showing you that all of these should be right here. But to make our periodic table look pretty and easier on one page rather than being so long, they just got all of those and they shoved them down here. Okay, let's keep going. Now, what does the actual period number tell you or indicate? It actually indicates the valence shells. What do you mean valence shells? I mean, if I have a oxygen atom, it's going to have protons and it's going to have neutrons in the center. And the first shell is going to have 2. 1, 2. Oxygen has a total of 8 electrons. 3, 4, 5, 6, 7, 8. That's what oxygen is going to look like. How many shells, how many of those rings does oxygen have? 1, 2. Now let's go to the periodic table and let's find oxygen. Here he is right here. Let's go sideways all the way to the side. And what row is he in? Look at that, row 2. So everybody in period or row 2 will have 2 shells. 2 shells. Everybody in period or row 4 is going to have 4 shells. Look at that. Is that not amazing on how the periodic table came together and organized? And not only does the columns tell you the number of valence electrons, and we talk about those, not these. And the periods, the rows or periods, yes, that are horizontally, everyone in period 7 is going to have 7 shells. 7 shells. That's crazy. So that's so nice to see how actually everything on this periodic table has a purpose and a reason for it. It says here that you are more like your family than you are like your neighbor. Your neighbor lives right next door to you. Look at these. Carbon and boron. They are right next door. They are neighbors. But carbon is not like boron at all. They're neighbors. Carbon is like silicon. He acts like germanium. He acts like tin and lead. They all act the same. They all have the same physical and chemical properties because they are family. This way, they're neighbors. All right. So that's just a saying that we have to just kind of help memorize a few things.